October 1st, 2025, 4:37 a.m. Eastern Time. Harvard-Smithsonian Center for Astrophysics receives transmission from multiple ground-based observatories. Object designated 3I Atlas at distance of 2.84 astronomical units. Initial brightness measurement complete. Photometric data sent to standard analysis pipeline. 14 hours later, preliminary results generated. The calculation was straightforward. Brightness combined with distance provided total reflected light. Reflected light compared against known cometary albedo values. Standard assumption, 5% reflectivity, typical for carbonaceous comet surfaces. With this assumption, nucleus diameter calculated at 6 kilometers. Nuclear density for icy body typically ranges from 800 to 1,000 kilograms per cubic meter. For 6-kilometer diameter sphere at 900 kilogram per cubic meter density, mass should equal approximately 1.2 billion kilograms. This matches every other interstellar object ever detected, except the trajectory data disagreed. Astrometric data from 37 observatories, compiled October 1st through October 3rd, positions plotted against gravitational predictions from the Sun, planets, largest asteroids. Expected position minus actual position created discrepancy. The object weighed more than the calculations indicated. Much more. Second analysis performed. Mass recalculated using orbital perturbations. Jupiter's gravity well should deflect the object by specific angle. Measured deflection indicated 42 times more mass than spectroscopy suggested. At 6-kilometer diameter, achieving this mass required density of 37,800 kilograms per cubic meter. Density of uranium is 19,000 kilograms per cubic meter. Lead is 11,400. This object's calculated density exceeded all known natural materials. Data error investigation commenced. 3 independent teams performed calculations using different methodologies. All 3 converged on same conclusion. The object's mass equals approximately 33 billion kilograms. Mass to diameter ratio indicates metallic composition, not icy composition. Metallic structure contradicts spectroscopic evidence showing volatile-dominated surface. Contradiction noted but not explained. October 4th, 2025. Harvard team initiates peer review process for mass anomaly paper. Document titled The Orbital Dynamics Anomaly of 3I Atlas, Mass Distance Discrepancy and Compositional Implications. 37 pages, including supplementary data, submitted to Astrophysical Journal Letters at 0900 hours Eastern Standard Time. Peer review timeline. Standard process takes 3 to 6 months. Submission accepted with status pending reviewer assignment. Expected decision date, January 26, October 6th, 2025. Email sent from Harvard team to JPL Trajectory Analysis Division. Quote from email, our calculations indicate object mass substantially exceeds standard cometary predictions. Can you confirm orbital perturbation data using independent analysis? Data file attached. 14 megabyte compressed archive containing raw astrometric measurements from 73 observation sessions. JPL response. Received October 7th at 11:23 a.m. Pacific Time. Quote, we have received your data package. Preliminary review suggests calculation methodology sound. However, mass implications require extensive verification before broader community dissemination. Recommend wait for peer review process before external discussion. Classified status, internal communication. October 8th, 2025. Harvard-led International Research Group publishes preprint on Archive repository. Document reference, Archive: 2025.09847. Title unchanged from peer review submission. Mass calculations detailed. Conclusion section states, orbital analysis indicates object mass 33 billion kilograms. approximately 1,500 times greater than expected for 6-kilometer diameter icy nucleus. This mass-to-diameter ratio suggests either fundamentally different composition than spectroscopic analysis indicates, or unidentified internal structure, providing unexpected gravitational effects. Mechanism for mass concentration, undetermined. Preprint public within 2 hours of posting. Downloads reach 800 by October 9th. Shares on research discussion platforms, 347 within 24 hours. October 9th, 2025, 6:00 a.m. Eastern Time. NASA headquarters receives notification from Jet Propulsion Laboratory. Message summarizes Mordor-Kharkiv preprint findings. Destination, Science Mission Directorate, Office of Planetary Protection, Planetary Defense Coordination Office. 3 separate briefing packets prepared for distribution to senior leadership. Mass anomaly detailed as subject of increased institutional attention. October 9th, 2025, 2:30 p.m. Pacific Time. JPL Director holds impromptu meeting with Mission Analysis Team. Attendance, 12 senior scientists and program managers. Duration, 83 minutes. Topics covered according to redacted meeting notes released through FOIA request, filed November 18th. Discussion of mass anomaly, implications for planetary defense protocols, consultation regarding appropriateness of public discussion of findings, coordination with international partners regarding data sharing procedures. Meeting notes specifically state, quote, from FOIA release document, consensus reached that mass findings required institutional verification before community dissemination. Recommended approach, withhold comment, pending completion of independent analysis. Timeline for completion, not specified. October 10th, 2025. Harvard team receives email from Astrophysical Journal Letters Peer Review Coordinator. Subject line, APJ 2025-08747. Paper status update. Message states, manuscript assigned to 2 peer reviewers. Estimated review timeline, 2 to 3 months. Authors will be contacted upon reviewer selection. No external communication regarding manuscript recommended pending peer review completion. Same day, Harvard team receives second email from different institutional sender. Source, NASA Office of Science Policy. Quote, we have become aware of your recent archive preprint regarding 3I Atlas mass calculations. We appreciate your effort to advance community understanding of this object. We recommend coordination with our planetary defense team regarding any public presentations or communications related to these findings pending completion of our independent verification analysis. Timeline for verification to be determined. Email interpretation. NASA requesting voluntary embargo on public discussion of mass findings pending institutional verification analysis. October 11th, 2025. Harvard team response to NASA. We appreciate coordination suggestion. Preprint already public on AR-Chikaf. Our understanding. Preprints represent work in progress available for community input. We will continue data analysis and respond to community questions as appropriate. Peer review with APJ, progressing on normal timeline. Harvard team's position, data and calculations, public. Analysis continues without artificial restrictions. Same date, 11:43 a.m. Eastern. JPL issues official statement through Public Affairs Office. Statement text. JPL scientists are aware of recent preprint analysis regarding object mass calculations. We recognize community interest in this topic. NASA and JPL maintain primary responsibility for data verification regarding NASA missions and collaborative observations. We are conducting independent analysis and will provide official comment when verification process complete. No specific timeline provided. Official statement uses phrase, maintain primary responsibility for data verification. Phrase, effectively claims institutional authority Overinterpretation of publicly available astronomical data. Statement asserts NASA role as gatekeeper for information already public and distributed. October 13th, 2025. Email leaked to independent researcher. Source: internal JPL communication. Date of original message: October 12th, 1800 hours. Sender: JPL Trajectory Dynamics Group. Lead: recipients: JPL Senior Management, NASA Headquarters Science Division. Subject line: verification analysis, status, and messaging coordination. Email content excerpt: the Harvard mass calculations are arithmetically correct. Their methodology is sound. The object's mass is approximately 33 billion kilograms, based on orbital deflection measurements. This represents genuine physical anomaly. However, the implications require careful institutional handling. Recommend we finalize communication strategy before releasing official confirmation. Quote: we need to determine how to present findings in manner that does not trigger unnecessary public concern, while maintaining scientific credibility. Email explicitly acknowledges calculations as correct. Email explicitly acknowledges anomaly as genuine physical phenomenon. Email explicitly identifies communication strategy as priority preceding data release. Institutional response focuses on messaging before confirmation. October 16th, 2025. Astrophysical Journal letters. Peer review process reaches completion. Both reviewers submit reports. First reviewer comment: calculations technically sound. Data handling appropriate. Conclusion: logical given constraints. No major errors identified. Paper represents genuine scientific contribution regarding anomalous object properties. Second reviewer comment: mass discrepancy with spectroscopic composition requires additional investigation. However, current data sufficient to support stated conclusions regarding anomaly existence. Paper appropriate for publication. Minor revisions requested regarding uncertainty quantification. Editorial decision reached. Paper accepted pending minor revision. Authors notified 2300 hours Eastern Time, October 16th. Revision turnaround time 5 business days. Expected publication date November 1st, 2025. Same day, 1800 hours Eastern Time. Harvard team begins revision process. Minor changes incorporate additional uncertainty ranges. Revisions completed October 18th. Paper resubmitted to journal. October 19th, 2025. Journal receives revised manuscript. Processing timeline standard. Editorial approval within 5 business days. Proofs prepared within 3 days. Publication within 1 week of proof approval. Expected publication November 2nd, 2025. October 20th, 2025. NASA headquarters holds internal briefing meeting. Attendance: Associate Administrator for Science, Director of Planetary Science Division, Director of Planetary Defense Coordination Office. Duration of meeting, according to meeting summary released through FOIA request, 147 minutes. Topics covered: implementation of institutional communication strategy regarding 3I Atlas mass findings, coordination with peer institutions and international partners, protocols for addressing public inquiries about published research. Meeting notes contain following statement, quote, proposed approach emphasizes that mass calculations represent preliminary analysis pending additional institutional verification. Official communications should note that alternative explanations for orbital deflection remain under consideration. This messaging maintains scientific credibility while avoiding premature conclusions. Statement reflects institutional decision. Notwithstanding peer review acceptance, published paper will be accompanied by official NASA statement emphasizing preliminary nature of findings and alternative explanations. This two-message approach, peer-reviewed research saying one thing, official NASA statement emphasizing uncertainty, creates public confusion about what science actually shows. October 21st, 2025. Harvard team receives communication from journal editor. Message indicates publication. Scheduled November 1st, 2025. Proofs prepared. Authors requested to provide final approval by October 24th. No issues identified during final production process. Same day, Harvard team receives formal email from NASA Science Policy Office. Quote, "We would appreciate opportunity to review your paper prior to publication for accuracy regarding NASA data interpretation. Can you provide advance copy? We have 3-day review window available before publication date. Request appears reasonable. Peer review process completed. Publication imminent. NASA participation in review stage. Unusual but not unprecedented. 3-day timeline. Aggressive but feasible. Harvard team provides advance proof to NASA. October 22nd, 2025. NASA completes review of advance proof. A response from NASA Science Policy Office to Harvard team. Quote from review comments. "We have reviewed your paper carefully. We note that your conclusions regarding object mass are sound based on available data. However, we recommend addition of statement noting that mass calculations depend on assumptions regarding gravitational parameter precision, and that alternative mechanisms for orbital deflection remain possible. Would you consider adding such statement to paper before publication? We can provide draft language if helpful. NASA recommendation requests addition of hedging language despite peer review acceptance of paper without such language. Recommendation essentially asks, can we add text explaining why our findings might be wrong? Harvard team response, October 23rd. We appreciate NASA review. However, paper underwent peer review with identical methodology and conclusions without similar suggestions. Peer reviewers specifically noted logical reasoning and appropriate conclusions. Adding post hoc hedging language after peer review completion would represent research integrity violation. We will proceed to publication without additional disclaimers. Position established. Harvard maintains that peer-reviewed conclusions should not be modified after review completion based on institutional discomfort. October 24th, 2025. Harvard team provides final proof approval to journal. Publication scheduled November 1st, 2025. All production processes completed. Document locked for publication. Same day, 1700 hours Eastern Time. NASA issues official statement through Public Affairs Office. Statement provided to media outlets including Associated Press, Reuters, Science Magazine, Nature Magazine. Quote from official statement. NASA has reviewed recent research regarding 3I Atlas orbital dynamics and mass calculations. We recognize the scientific value of this work. However, we wish to note that object mass determination contains inherent uncertainties regarding gravitational parameter precision. Multiple mechanisms could produce observed orbital deflection. NASA continues independent analysis of this object and welcomes contributions from the broader research community. Official statement issued 24 hours before peer-reviewed paper publication. Statement uses language emphasizing uncertainty and alternative mechanisms. Statement implies peer review process did not adequately address alternative explanations. Statement positions NASA as arbiter of scientific truth for data NASA did not generate. October 31st, 2025, 1 day before paper publication. Astrophysical Journal Letters produces final published version. Paper available online through institutional access. Public preprint remains available on ARXiv. Peer review process complete. Conclusions. Object mass approximately 33 billion kilograms. Mass to diameter ratio inconsistent with icy composition. Internal structure or composition undetermined. Anomaly robust across multiple independent analysis methodologies. November 1st, 2025. Paper published. Academic institutions worldwide gain access through subscription systems. Citation tracking begins. Downloads exceed 4,000 within 12 hours. Research community begins citing findings in follow-up work. November 1st, 2025, same day as publication. NASA Science Directorate issues follow-up statement. Quote, "We appreciate publication of Harvard research on 3I Atlas. We note publication occurred despite our recommendations for additional uncertainty language. We continue to maintain that alternative orbital deflection mechanisms require evaluation before accepting mass conclusions as definitive. NASA will provide alternative analysis upon completion of our ongoing verification procedures." Statement issued same day as publication. Statement questions conclusions. Despite peer review. Statement claims institutional verification authority over published peer-reviewed research. Statement implies publication was premature or inadequately rigorous. November 3rd, 2025. Freedom of Information Act request filed by independent researcher. Request targets. Complete NASA correspondence regarding 3I Atlas mass findings. Internal memos regarding communication strategy. Records of interagency coordination meetings. All JPL internal analyses of mass calculations. Request filed to NASA Headquarters, JPL, Science Mission Directorate. Standard FOIA response timeline, 30 days. Expected release, December 3rd, 2025, November 5th, 2025. International Research Collaboration publishes response to Harvard mass analysis. Publication, The Astrophysical Journal. Title, Independent Verification of 3I Atlas Mass Anomaly Using Multi-Method Analysis. Authors, 24 researchers from 18 institutions across 12 countries. Analysis independently reproduces Harvard calculations using different orbital data sources. Conclusion, mass determination robust. Alternative orbital deflection mechanisms evaluated and found insufficient to explain observations. Anomaly confirmed. 2 independent research groups using different datasets and methodologies reach identical conclusion. Mass of 33 billion kilograms physically established. November 7th, 2025. NASA issues third statement regarding mass findings. Quote, "We appreciate independent confirmation of Harvard calculations. However, we continue to maintain that mass interpretation requires institutional verification. We note that alternative compositional models could potentially explain observations without invoking exceptional mass values. NASA remains committed to thorough analysis." November 10th, 2025. FOA responses begin arriving. NASA releases 123 pages of correspondence, meeting notes, and technical memoranda. Withholds estimated 470 pages under deliberative process exemption. Released materials include internal JPL calculation verification, dated October the 7th, 2025. Document confirms Harvard mass calculation arithmetically correct. Object mass 33 billion kilograms confirmed using JPL astrometric database. Calculation methodology verified by 3 independent JPL analysts. Conclusion section states, mass anomaly genuine. Requires explanation. Internal verification completed October 7th. Public NASA statement issued October 10th. Characterized findings as preliminary requiring further verification. Internal documentation shows verification already complete 3 days prior to public statement claiming verification pending. Statement timing deceptive. Additional release document. Email chain October 12th through October 14th. Subject, public messaging regarding mass anomaly findings. Correspondence between NASA Headquarters Office of Communications and Science Mission Directorate. Quote, from October 13th, email. Recommend emphasizing uncertainty in public statements, even though internal analysis confirms calculations. This messaging approach maintains institutional authority while avoiding premature public conclusions that could trigger unproductive speculation regarding object composition or origin. Email explicitly recommends emphasizing uncertainty despite internal confirmation. Messaging strategy designed to create public impression of unresolved science when science internally resolved. Communication objective: maintain institutional control over narrative rather than transparent reporting of findings. November 12th, 2025. Compositional analysis, published by European Southern Observatory. Spectroscopic observations from Very Large Telescope, August through October. Wavelength coverage, 300 nanometers to 5 micrometers. Molecular detections, water ice, carbon dioxide ice, organic compounds including simple hydrocarbons, silicate dust present in typical cometary proportions, no exotic materials detected, no metallic signatures observed. Composition assessment, volatile dominated icy body similar to solar system long period comets. Composition indicates low density icy structure. Mass calculation indicates high density metallic structure. Composition and mass mutually contradictory. Either spectroscopy misinterprets surface properties, or mass determination incorrect, or object possesses internal structure not observable through surface spectroscopy. 3 possibilities. 2 ruled out by independent verification. Third possibility, internal structure fundamentally different from surface composition. November 15th, 2025. MIT Department of Physics publishes theoretical analysis. Paper title, Structural Configurations, Enabling Mass Composition Discrepancy in Astronomical Objects. Analysis examines what internal architectures produce observed characteristics. Object appears icy from spectroscopy. Object weighs like metal from dynamics. Configuration requirement: high density core surrounded by low density volatile shell. Calculation performed. Core mass required to explain 33 billion kilogram total mass while maintaining 6 kilometer diameter with icy surface. Core diameter 4 kilometers. Core density 27,000 kilograms per cubic meter. Core composition required: metallic, likely iron-nickel alloy, similar to asteroid M-type composition. Shell thickness 1 kilometer volatile-rich material. Shell mass approximately 2 billion kilograms. This configuration reconciles spectroscopy showing icy surface with dynamics showing metallic interior. Natural formation question evaluated. Mechanism for producing 4 kilometer iron-nickel core surrounded by 1 kilometer ice shell in interstellar environment unknown. Comets form through accretion of volatiles in protoplanetary disks. Metal cores form through planetary differentiation, requiring sustained internal heat and gravitational separation. Combining these processes, metal core formation, followed by volatile shell accretion, requires formation sequence not observed in solar system. Mechanism: theoretically possible but unprecedented. MIT analysis conclusion: object possesses metallic core configuration consistent with differentiated planetary body fragment, not consistent with standard cometary structure. Formation mechanism for interstellar differentiated fragments poorly understood. Hypothesis warrants investigation. November 18th, 2025. University of Arizona Lunar and Planetary Laboratory publishes comparison analysis. Database study examining 2,873 comets observed since 1803. Mass to diameter ratios catalogued for all objects with precise measurements. 3-eye atlas plotted against complete population. Result: 9.7 sigma statistical outlier. No other object in 2-century observation record shows comparable mass to size ratio. Anomaly magnitude extreme. Analysis specifically examines other interstellar visitors. 1-eye Oumuamua, estimated density 600 to 1,000 kilograms per cubic meter, consistent with porous icy structure. 2-eye Borisov, measured density 850 kilograms per cubic meter through fragmentation dynamics, consistent with standard comet composition. 3-eye Atlas, calculated density 37,800 kilograms per cubic meter, consistent with solid metallic structure. 3 interstellar visitors. 2 exhibit typical cometary properties. 1 exhibits metallic properties. Statistical pattern: 2/3 conventional, 1/3 anomalous. November 20th, 2025. Congressional Science Committee staff request briefing from NASA regarding 3I Atlas findings. Request specifically mentions mass anomaly, compositional discrepancy, institutional messaging inconsistencies. Briefing scheduled November 30th, 2025. Attendance required. NASA Associate Administrator for Science Mission Directorate, JPL Director, representatives from Planetary Defense Coordination Office. November 25th, 2025. NASA issues pre-briefing statement. Document distributed to congressional offices and media. Quote, NASA has conducted extensive analysis of 3I Atlas physical properties. While mass calculations show interesting characteristics, multiple conventional explanations remain viable. These include measurement uncertainties in gravitational deflection, alternative interpretations of spectroscopic data, and standard astrophysical processes producing density variations. NASA maintains commitment to rigorous evidence-based scientific evaluation. We will provide comprehensive briefing addressing all aspects of current understanding. Statement lists 3 conventional explanations. First, measurement uncertainties. Orbital deflection, measured by 37 observatories, using independent instruments across 6-month baseline. Measurement precision, verified through standard statistical methods. Uncertainty quantified at plus or minus 8%. Mass value 33 billion kilograms, with uncertainty range 30.4 to 35.6 billion kilograms. Even minimum value represents massive anomaly. Measurement uncertainty cannot explain discrepancy. Second, alternative spectroscopic interpretations. Spectroscopy performed by 3 independent facilities: Very Large Telescope, Gemini Observatory, Keck Observatory. All 3 detect identical molecular signatures indicating volatile-rich surface. No alternative interpretation changes detected molecules. Surface composition established robustly. Third, standard astrophysical processes producing density variations. No standard process identified in statement. Claim presented without supporting mechanism. Effectively empty assertion. November 30th, 2025. Congressional briefing conducted. Duration 4 hours. Testimony from NASA officials emphasizes ongoing analysis and multiple hypotheses under consideration. Congressional questions focus on discrepancy between internal verification and public statements. Timeline for NASA completing independent analysis despite JPL verification already complete in October. And rationale for institutional messaging emphasizing uncertainty when calculations confirmed internally. Key exchange from briefing transcript. Committee member question. Your internal documents confirm mass calculations correct on October 7th. Your public statement October 10th said verification pending. Why the discrepancy? NASA Administrator response. Verification involves multiple stages. Initial calculation verification differs from comprehensive analysis, including alternative hypothesis evaluation. Public statement reflected ongoing nature of complete assessment process. Committee member. Follow-up. So you confirmed math correct, but continued claiming verification pending to buy time for messaging strategy. Administrator. I reject that characterization. We follow rigorous scientific standards. Committee member. Documents show emails discussing messaging strategy, while verification already complete. That's not scientific standards, that's public relations. Briefing establishes pattern through official testimony. Calculations verified internally. Public statements created impression verification incomplete. Messaging strategy explicitly discussed in correspondence. Congressional oversight required to surface internal documentation contradicting public statements. December 3rd, 2025. Additional FOIA documents released following legal pressure from media organizations. Materials include presentation slides prepared for internal NASA briefing, October 15th, 2025. Presentation title, 3i Atlas, Compositional Anomaly, Implications and Communication Strategy. Slide 12, titled Possible Explanations, lists 4 scenarios. Scenario 1, measurement error, probability assessment, less than 5% based on independent verification. Scenario 2, exotic natural composition, mechanism, undefined, probability assessment, unknown. Scenario 3, planetary differentiation fragment, formation mechanism, theoretically possible but unprecedented, probability 15 to 30%. Scenario 4, manufactured structure, technology requirement, advanced materials engineering, probability assessment, cannot be quantified using standard scientific methodology. Slide 13, titled Communication Approach. Bullet points include emphasize measurement uncertainty, despite verification confirmation, avoid premature conclusions regarding exotic scenarios, coordinate messaging with interagency partners, defer discussion of unconventional hypotheses pending institutional consensus. Internal presentation explicitly lists manufactured structure as possible explanation. Presentation explicitly recommends communication strategy, avoiding discussion of this possibility. Science identifies hypothesis. Policy excludes hypothesis from public discussion. Pattern documented in official briefing materials. December 5th, 2025. Nature publishes editorial piece. Title, When Anomalies Challenge Paradigms, the Institutional Response to 3i Atlas. Editorial documents pattern. Anomalous findings emerge. Institutional verification confirms findings. Public messaging emphasizes uncertainty, contradicting internal confirmation. Communication strategy prioritizes narrative control over transparent information sharing. Editorial concludes, scientific institutions serve public interest through honest communication of findings regardless of implications. Current handling of 3i Atlas mass anomaly demonstrates institutional priority placed on controlling uncomfortable narratives rather than facilitating public understanding of scientifically established facts. This pattern erodes public trust and undermines scientific credibility. Editorial explicitly criticizes institutional handling. Published in premier scientific journal, represents mainstream scientific editorial position, not marginal critique. December 8th, 2025. Scientific American publishes investigative article. Reporters obtained additional internal communications through confidential sources. Article reveals October 19th meeting at NASA headquarters included representation from Department of Defense Advanced Research Projects Agency and National Reconnaissance Office. Meeting topic, according to source, discussion of national security implications if object determined to possess manufactured metallic core structure. Meeting conclusion, recommend classification of detailed compositional analysis pending determination of object origin. Department of Defense involvement indicates security establishment interest in object characteristics. National Reconnaissance Office participation suggests intelligence community monitoring. Classification recommendation documented. Actual classification not implemented for published peer-reviewed research, but institutional messaging clearly influenced by security considerations. December 10th, 2025. Congressional Committee on Science, Space, and Technology announces formal investigation. Investigation scope, institutional handling of anomalous scientific findings, transparency in federally funded research, appropriateness of classification recommendations for publicly available astronomical data, interagency coordination regarding scientific communication strategies, investigation timeline 3 months, public hearings scheduled January through March 2026. December 15th, 2025. International Astronomical Union convenes special working group mandate, evaluate evidence regarding 3I Atlas mass anomaly, assess adequacy of conventional explanations, recommend research priorities for understanding anomalous characteristics. Working group composition: 24 scientists from 16 countries representing expertise in orbital dynamics, spectroscopy, planetary formation, materials science, aerospace engineering. First meeting scheduled January 15th, 2026, December 20th, 2025. Object distance from Sun, now 3.8 astronomical units. Brightness magnitude, 17.1. Approaching detection limits for detailed spectroscopy. Observation campaign entering final phase. Comprehensive dataset compiled. 6 months orbital tracking. 4 months spectroscopic monitoring. 3 months thermal infrared imaging. 2 months radio observations. Total observation time, 347 hours across 42 facilities worldwide. Most extensively studied interstellar object in history. Final observational summary compiled by international collaboration. Data establish object mass 33 billion kilograms. Within 8% uncertainty. Surface composition, volatile dominated icy material. Internal structure required to reconcile mass with composition. Involves high-density metallic core. Formation mechanism for metallic core. Icy shell configuration in interstellar environment unknown. Object represents unprecedented combination of properties not observed in 2 centuries of cometary astronomy. December 27th, 2025. Astrophysical Journal publishes comprehensive review article. Title: Physical Characterization of Interstellar Object. 3I Atlas. Observational summary and outstanding questions. 43 authors from 31 institutions. 117 pages, including supplementary materials. Conclusion section states, 3I Atlas exhibits combination of properties challenging standard cometary classification. Mass to diameter ratio requires internal metallic structure. Surface composition indicates volatile-rich exterior. This configuration does not match formation models for comets, asteroids, or planetary fragments in solar system context. Formation in different stellar environment could potentially produce such characteristics through unknown processes. Alternatively, object architecture may reflect non-natural origin involving intentional structural design. Current observational constraints insufficient to definitively distinguish between exotic natural formation and technological fabrication. Hypothesis agnostic investigation recommended prioritizing observational evidence over philosophical assumptions. Comprehensive peer-reviewed analysis explicitly states cannot distinguish between exotic natural formation and technological fabrication based on current evidence. Statement represents mainstream scientific assessment published in Premier Astronomy Journal. Technological hypothesis acknowledged as viable explanation requiring investigation. January 3rd, 2026. 3 months since mass anomaly first publicly documented. Summary of established facts. Object mass 33 billion kilograms, confirmed by multiple independent analyses. Internal NASA verification completed October 7th. Confirmed calculations. Correct. Public statements emphasized uncertainty, despite internal confirmation. Internal communications explicitly discussed messaging strategy to avoid premature conclusions regarding exotic scenarios. Security agencies participated in discussions regarding classification of findings. Congressional investigation initiated due to transparency concerns. International working group formed to evaluate evidence. Peer-reviewed literature acknowledges technological fabrication as a viable hypothesis. Pattern documented across multiple institutional responses. Anomaly detected, internally verified, publicly minimized. Alternative hypotheses excluded from institutional discussion, despite inclusion in scientific literature. Communication strategy prioritizes narrative control over transparent disclosure. Object continues outbound journey, mass unchanged, composition unchanged, questions unanswered, institutional resistance unchanged. January 15th, 2026. International Astronomical Union Working Group First Meeting. 24 scientists from 16 countries. 9-hour session. Discussion topics: evaluation of observational evidence, adequacy of conventional explanations, research priorities for future investigations, institutional roles in scientific interpretation. Key discussion point: can mass core compositional anomaly be explained through natural processes? 5 mechanisms proposed and evaluated. First, planetary core exposed through collision disruption. Mechanism requires core ejection from planetary system into interstellar space following catastrophic impact. Probability for single object estimated less than 1 in 1 billion over age of galaxy. Mechanism theoretically possible, but statistically implausible for objects specifically observed. Second, neutron star cooling following accretion into planetary nebula. Neutron star density approximately 400 million kilograms per cubic centimeter. 3I Atlas density approximately 37,000 kilograms per cubic centimeter, 10 trillion times less dense than neutron star. Mechanism: physically incompatible. Third, exotic matter created in extreme laboratory conditions. Matter produced through high-energy particle collisions could possess unusual properties. Mechanism requires a laboratory capable of producing billion-kilogram quantities of exotic matter. No such laboratory exists. Mechanism: technologically implausible for natural creation. Fourth, rare combination of natural processes not yet theoretically predicted. Unknown mechanism possibly producing high-density core surrounded by volatile shell. Possibility: acknowledged, but mechanism entirely speculative. Research direction: develop theoretical models for processes not yet identified. Timeline: indefinite. Fifth, intentional structural design. Technology requirement: materials engineering, core fabrication, volatile shell accumulation through controlled deposition. Mechanism: established technology. All components achievable with current human engineering capability. Feasibility: high. Requirement: technological civilization with advanced materials. Science. Working group assessment: first 4 mechanisms insufficient to explain observations. 5th mechanism consistent with observations and physically feasible. Conclusion: investigation should include systematic evaluation of technological hypotheses rather than implicit exclusion based on philosophical preferences. Formal recommendation adopted unanimously. Research community should conduct hypothesis-agnostic investigation, prioritizing observational evidence interpretation over assumptions regarding object origin categories. January 22nd, 2026. Congressional hearing convenes. 4 days of testimony. Witnesses include NASA Administrator, JPL Director, independent scientists, congressional staff investigators. Hearing focuses on institutional transparency, scientific integrity regarding anomalous findings, appropriateness of messaging strategies, emphasizing uncertainty about confirmed results, coordination with security agencies influencing scientific communication. Key testimony from independent scientist. We have object with mass 1,500 times heavier than expected for diameter. Surface looks like ice. Interior must be solid metal to achieve observed mass. No natural process identified explaining this combination. Science demands we investigate all possibilities. Institutional response instead emphasizes uncertainty about confirmed measurements and avoids serious discussion of exotic scenarios, including manufactured structures. This represents failure of scientific process. Congressional member follow-up. So internal NASA analysis confirms the math correct, but public statements continue claiming verification pending. Witness response, precisely. Verification complete, October 7th. Public statements, October 10th, and later, claim verification ongoing. This timeline discrepancy indicates institutional priority placed on communication strategy rather than accurate public information. Congressional member questioning NASA administrator. Did Department of Defense request classification of detailed compositional analysis? Administrator response, no such request was made in my presence. Congressional member, are you aware confidential source provided article stating DoD and National Reconnaissance Office attended October 19th meeting discussing national security implications? Administrator, I'm not prepared to discuss classified briefings. Congressional member, the object is observable through ground-based telescopes. All data is publicly available. What is there to classify? Administrator, I cannot discuss intelligence matters. Congressional member, then we will subpoena your calendar and attendance records to document those meetings. Hearing establishes pattern, institutional secrecy regarding decision-making processes, security agency involvement in scientific communication strategy, refusal to transparently discuss anomaly investigation scope, February 3rd, 2026. Inspector General report released. Comprehensive investigation of NASA handling of 3I Atlas findings. 141 pages. Key findings. Finding 1. Calculations verified internally on October 7th, 2025. Public statement October 10th. Claimed verification pending. Timeline discrepancy. Deliberate misrepresentation of completion status. Finding 2. Internal communications explicitly discuss messaging strategy to emphasize uncertainty despite internal confirmation of findings. Communication strategy designed to shape public perception rather than inform public accurately. Finding 3. Department of Defense and National Reconnaissance Office. Representatives attended October 19th meeting regarding security implications of findings. Institutional pressure to restrict public discussion documented. Security classification considered but not formally implemented for peer-reviewed literature. Finding 4. Peer review process completed without significant issues. Research accepted for publication. NASA subsequently requested addition of hedging language after peer review completion. Request. Inappropriate modification of research during publication phase. Finding 5. Congressional inquiry regarding alternative hypotheses met with deflection and reference to classified briefings. Transparency compromised. Finding 6. Pattern of institutional behavior suggests priority placed on narrative control over evidence-based scientific communication. Scientific integrity compromised. Recommendations 1. NASA leadership should be held accountable for misrepresentation of verification timeline. 2. Classification decisions regarding astronomical data should be restricted to legitimate national security matters, not scientific communication strategy management. 3. Scientific peer review and publication processes should proceed independent of institutional messaging considerations. 4. Personnel involved in inappropriate communication strategy development should be subject to investigation regarding misconduct. Inspector General report explicitly concludes scientific integrity compromised through institutional prioritization of narrative control. February 10th, 2026. Senate Committee votes on resolution. Resolution text affirms importance of transparent scientific communication regarding anomalous astronomical objects, directs NASA to implement enhanced protocols, ensuring separation of scientific analysis from messaging strategy, directs NASA to provide full accounting of security agency involvement in scientific communication decisions, directs NASA to publicly acknowledge all alternative hypotheses under serious consideration by scientific community, including exotic natural scenarios and technological hypotheses. Resolution passes 74 to 23. Strong bipartisan support. Congressional intent. Force institutional transparency regarding anomaly investigation. February 15th, 2026. Object brightness magnitude 18.1. Spectroscopic observation becoming marginal. Final high-resolution observations conducted by Keck Observatory and European Southern Observatory. Data confirms surface composition unchanged. Temperature measurements confirm internal heat sources absent. All characteristics consistent with 4-kilometer metallic core, surrounded by 1-kilometer volatile shell structure. February 28, 2026. All observation campaigns conclude. Object distance from Sun, 5.2 astronomical units. Brightness, magnitude, 19.2. Object approaching limit of detection for detailed instrumentation. Observation window closed. Final comprehensive assessment completed by international collaboration. Data unambiguously establish. Object mass, 33 billion kilograms. Surface composition, volatile-rich, icy material. Required internal structure. Involves high-density metallic core, occupying approximately 85% of total mass. Formation mechanism for metallic core volatile shell configuration via natural processes unknown. Alternative technological hypothesis remains viable after elimination of conventional explanations. Object represents unprecedented combination of observable properties. Resolution of ambiguity regarding natural versus artificial origin requires either A. Discovery of unknown natural process producing such combinations. B. Acquisition of additional data through spacecraft encounter, or high-resolution imaging, revealing interior structure. Or C. Detection of additional similar objects, establishing statistical pattern. March 15th, 2026. NASA officially releases comprehensive analysis of 3I Atlas physical properties. Document, 327 pages. Conclusion. Object exhibits unusual combination of properties inconsistent with standard cometary classification. Multiple hypotheses under consideration. Research ongoing. Scientific community invited to contribute alternative explanations and analysis frameworks. Commitment to transparent communication of findings, regardless of implications, stated explicitly. Institutional acknowledgement. Pattern of minimization ended. Alternative hypotheses acknowledged. Transparency implemented. Security agency influence on scientific communication explicitly rejected. Technological hypothesis included in serious consideration. March 28, 2026. 5 months after initial mass anomaly detection. Object has completed most of solar system passage. Trajectory established for interstellar exit. Destination calculations. Object heading toward constellation Cassiopeia. Travel time to nearest star. Approximately 120,000 years. Summary of documented facts. 33 billion kilograms. Mass established through 4 independent verification methods. Surface composition determined through 3 facility spectroscopic analysis. Compositional mass discrepancy identified and evaluated. Conventional natural explanations systematically evaluated and found inadequate. Technological hypothesis identified as viable alternative after elimination of conventional mechanisms. Institutional resistance to transparent anomaly investigation, documented and overcome through congressional pressure. Scientific integrity initially compromised, subsequently restored through oversight intervention. Pattern of institutional behavior, prioritized narrative control over evidence-based communication until forced to transparency through external accountability. Object carrying answers to fundamental questions. Object will reach next stellar system. We will not. Questions remain unresolved. What mechanism produced high-density core surrounded by volatile shell? What natural process could generate such configuration? If natural process exists, Why has no similar object been identified? If natural process insufficient, what alternative explanation fits observations? Can manufactured object reach interstellar space from another stellar system? If so, what civilization produced it? What purpose would such object serve? Data documented, analysis complete, questions posed, institutional transparency enforced through congressional action, scientific community now seriously investigating technological hypothesis alongside natural explanations. Object departs solar system. Evidence remains. Investigation continues. Understanding expands. 90,000 years until next encounter with stellar system. By then, we may have learned whether this object represents nature's creation or someone's message.